Good morning, everyone. My name is Sarah Marks, and along with my partner Enrico Aranha, we will be presenting about Brazilian stingless bees and how our work with them relates to the Blue Marble Space Institute of Science. This project falls under the nonprofit of Beeworks. Our project is called Adopt a Bee, Plants and Sensors. Our mentor was Dr. Lev Harajski. So first, what is Beeworks, and how does it relate to the Blue Marble Space Institute of Science? So Beeworks is the specific project that we created sensors and an app for. Beeworks falls under a nonprofit called Science Voices, which is a nonprofit for science education. Science Voices has many different projects, including a Greenworks division that has various ecologically minded projects with collaborators in Indonesia, in Ukraine, in Brazil, and in the United States. So kind of all across the globe. The Beeworks project specifically works on bee education with local communities in the Guapapiro region of Brazil. The project is in collaboration with the University of Campinas, as well as local farmers, local school children, the local community. It's in a forested region where they do a lot of agroecology, which is kind of a culmination of the environment, the forest, growing bees. The important thing is to work on economic growth in the region, teach local people how to keep local bees to kind of keep the economy in a local manner rather than using the typical farming European honeybee, which is not native to the region. So we'll talk briefly about stingless bees before diving into the rest of the project. Stingless bees are in almost every continent on the world, but they flourish most in the tropics. They range in size from being smaller than a fruit fly to being larger than Apis mellifera, the European honeybee. This photo was taken by Lev, our mentor, showing the kind of interesting wax formation that stingless bees form on the outside of the hive, which I had never seen before. And I thought was very interesting. And so stingless bees obviously can't sting, although some species can bite. And one of the reasons why this project works so well with the community is because lots of people are allergic to bees. Lots of people are afraid of being stung. That can be kind of a barrier to beekeeping. But working with stingless bees that have a gentle bite or no negative physical impact at all if you bother them, it can be an easy way for children to get excited about beekeeping. And the reason why stingless bee conservation is important, especially with endangered species, is because they're so well adapted to their kind of local niches in the ecosystem. Stingless bees can pollinate passion fruit by doing a kind of vibration pollination, which is way more effective than non-native bees. Stingless bees can have stronger wings in order to open Brazil nut flowers better.
Hello, that's my part. So our project had like this two sub projects. The first one is the app that we're going to talk about right now. So when I entered the project, it already had this prototype, and I'm showing this to you because it gives a good idea of how the app should work and its main goals. So the idea is that users can adopt virtual bees to receive their messages and view their stats and like have like this almost like a Pokemon that they'll have and send messages to you about their life. A secondary goal is to educate the users about the stingless bee behaviors. So the messages would be based on their actual behaviors, their life, actual life cycles, and their environment. So it would be like this really to users to really get to know like how those bees like live and how their environment is. And so, but the main goal is to fund other environmental projects. of science voices. So I'm going to talk more about this later, but you will pay to have like you have like a subscription to get like some base, and this money would be used to fund other projects, important projects on science voices and projects in Brazil. Sarah, you can go to the next slide. Okay, so now to talking about the work that I did, the- we decided to do this more compact version. It has only three screens. The first one is the feed screen. It shows the messages that the bees generate from time to time. They're saved on an internal list. Basically, it's the user data. You have like uh, from time to time the bee generates a message and it goes to a list of messages, and you generate the app like gets all of them in order for the user to see it. We had like I developed some working filters, so you can filter by the most recent, the since last login, and by a specific bee. I think that's the main part of it. It still don't have like some functionalities like info pop-ups. In the prototype, you have like for example, Jabuticaba tree. You would have like this highlighted. User would click and learn about it, but it's already in a good form. You can go to the next slide. The second part is the B screen. Here you would have this adoption list. So you have the eggs that when they hatch and the active B cards. So here's Gabriella. You can see when she hatched, how much the distance that she has flown, the pollen collected, and other stuff like that. And below this part, you can check the past bees, that bees profile. So you have like this small profile with their picture, name, birth date, and the death reason. So Maria Sofia here flew too close to the sun. So it would have like this kind of funny uh, things and to keep the user active. You can pass to the next slide. The third screen that I made is the shop screen. The idea is that it is a card, like a user card, and you can you can add unlimited bees like these cards. Like you can have a lot of those, like unlimited. And I have to fix that later because I think that unlimited is a very big number for an app. But you can customize the base that you're going to buy. And the idea is $1 a bee. You want to have more bees, you're gonna pay like uh, the same amount in dollars. So I want like 7 bees. You would pay a subscription for $7, and if somehow all of them die like in the same day, they would respawn like an egg, so you would pay like to have like this recurring 7 bees always on your inventory. So you can pass to the next slide. Okay, the final part of this app development is the systems that we wanted to use. We plan to use alternative billing systems to try to lower the fees because like $1 a bee, it can, depending on the fee, you can get like all of the money of the subscription. And after a lot of confusing research, we decided that the best for this part of the billing systems would be to use the Play Store or App Store already native systems. It had lower fees. It's simple to use, so we decided it would be better. Another important part is the first idea would be that we had through the messages would be to generate these B messages via an API. And by the way, I forgot to explain what an API is. If you guys don't know, you can basically See, it's the most popular example, but it works. Everyone says it works. It really does. But it's like an emulator. So if I use the OpenAI API to generate a message, basically I have like this prompt in my code. I go to the API. The API sends it to the OpenAI server. They generate the message, and the API brings it back to me for me to use. Basically, this is the idea: is to like get uh, like a service from uh, someplace. Like it can be the Play Store. The billing system is also an API, but ChatGPT is, I think, the most clear example. We wanted to use we wanted to generate messages every time. So every time we wanted to wanted to generate a message like on the app, the time was due, we would call this API. But after researching a little bit and using a little of the FX module things from YSP, uh, we decided that the best decision would be to how can I say? The best decision would be to generate the messages in batch because it would be more efficient energetically. Uh, because I think the best thing we could do would be we needed to use the AI, right? Because it would help the project a lot, will accelerate things a bit. But okay, we needed to make sure as part of an environmental project to not to like use something like that in an irresponsible way. So for me, that was like a highlight of the project, like thinking about our decisions and the project, where the project would go. And I think that's it. Now the next part is with Sarah.
All right. The next part, I'm going to talk, and I know we're low on time, so I'll make it fast. Talking about the components that I was developing for a low-cost bee sensor. So my goal was to work on developing a sensor that can tell temperature and humidity, time and date information, as well as simply counting bees that are going in and out of the hive. So I used phototransistors in pairs. So I worked with two sets of two, 4, and 6 phototransistors to be able to count 1, 2, and 3 bees that are going into a hive at the same time. And when I paired these with a couple of different temperature and humidity sensors to try and find one that seemed to be the most accurate. In order to track the time, or like have a place to put this data, I used a real-time clock module in my prototyping board, as well as an SD card that carried all the data. In this picture, on the left, you can see my thumbnail and how small the bee counting sensor itself is. And on the right, you can see the prototyping board that was very messy when I was trying to figure out the best method to connect everything. So how does the sensor work? Those small sensors, the one that fit on the thumbnail, can tell you a threshold value. That threshold is arbitrary. You can play with it depending on the size of the bees that are entering. That's something that will later need to be determined during field testing. This photo of me in a beekeeping suit is not from this project because I didn't work on with stingless bees. That's when I've tested different types of bee sensors in other hives. You put 2 of the sensors in a line, and if the bee goes past the first sensor and then the second sensor, it counts the bees going in. If it counts the bee going past the second sensor and then through the first sensor, it knows it's coming out. This can be expanded. I tested it using multiplexers to synthesize larger quantities of bee data coming in, but for purposes of simplicity, I did my tests with just 2 sensors to count 1 bee at a time. And then what can we do with this data? The ultimate goal is to connect it to the app. So everything is combined. We can make learning about bees engaging and dynamic. You can understand how your hive health is relating to seasons, the weather, where you've put your hives, how you're moving them. And then finally, you can check on all your hives at the same time if you have them connected to a sensor so that you can farm larger amounts of bees at once. And finally, hopefully this will get students excited about it. And then Enrico will talk briefly about the future of the app, and then we'll talk about the sensor.
So about the app, we still have to implement these APIs of the app stores. We want to create a more complex message page creation system with tags. So the message would be sent based on the personality tags, action, season, climate. Another, we also need to develop other important features like recurring message creation. It still doesn't exist on the actual version of the app, and develop other screens and other features. We haven't decided yet, but it's basically this. You can talk, Sarah.
And then the future of the sensor, ideally, the bee count will be able to be seen on the app. And eventually, we want to have a machine learning model where we can have a camera looking at bees coming in the hive and counting it that way. Finally, thank you. It was a really interesting program, and we both learned a lot.